In this presentation, the Advanced Correlator Navy Multi-Intelligence, Ship Track Data Fusion, and associated present behavior and pattern of life processors will be described. The Advanced Correlator Navy, or ACORN, data fusion processor has shown excellent results in the detection, tracking, classification, and identification of threats of high interest in 5 Navy Trident Warrior exercises, and in processing sensor data recorded in Western Pacific areas of interest. The present behavior and pattern of life processors will be described. The present behavior and pattern of life processor is designed to collect track data over several years to characterize the behavior of certain ship types, such as military combatants, fishing vessels, and cargo ships in specific fixed areas of interest. Jove Sciences Inc., or Jove for short, is a high-technology company specializing in maritime ship tracking, pattern of life behavior algorithm development, oceanography, underwater acoustics, anti-submarine warfare, Arctic acoustics, ocean wave energy, quantum computing, and many other areas. The recent success of the ACORN processor on major data from adversary naval combatants has led to a significant increase in funding levels, and Jove desires a teammate to help market its successful technology and transition this technology via SBIR Phase 3 contracts. Jove has senior programmers and analysts with top-secret, sensitive compartmented information clearances, and a most valuable cooperative research and development agreement with the Naval Information Warfare Center Pacific, which allows the recording of many satellite and tactical data worldwide at any time and in any area. The detection, tracking, classification, and identification of adversary naval combatants and their support ships hiding among commercial ships and shipping environments is a critical current Department of Defense capability gap being successfully addressed by the ACORN and pattern of life processors. The NAVAIR Monitor program of record has funded Jove with a SBIR Phase 2.5 contract to build the Monitor ACORN sidecar for both military DoD missions and commercial applications, such as the detection, tracking, and classification of IUU fishing vessels, drug runners, pirate ships, illegal arms carriers, and other applications as depicted on this view graph. This effort is showing excellent progress to date. Jove is demonstrating the capability for both Monitor and commercial applications. As this view graph shows, the ACORN data fusion processor and its associated pattern of life processor are connected. The ACORN data fusion processor ingests numerous sensor sources, including the integrated broadcast system data feed. The primary objective of the ACORN data fusion processor is to output accurate multi-sensor tracks to both the Navy operator and the pattern of life processor. The pattern of life processor calculates the ship track statistics and detects 7 types of anomalous behavior events. For AIS ships, these events are 1. Using a bogus ship name or MMSI number. 2. Going AIS dark. 3. Broadcasting position reports showing excessively high speeds. 4. Frequent changes in course and speed. 5. Rendezvous at sea. 6. Spoofing ship type. And finally, operating out of the ship's normal ocean area. Currently, data fusion processors output tracks, but do not input them into a pattern of life processor and store them in a database as shown in this data flow diagram. This is a total waste of ship track data that could be used for pattern of life assessments. Jove is designing a worldwide system where all ships would collect track data for a pattern of life database. An onshore processing facility would integrate the data into a single pattern of life database for specific ships. The pattern of life processor for ships emitting ELINT and not AIS messages can be covered at a classified level. Currently, the ACORN data fusion processor is written in Java and has been tested at sea on many datasets. A sensor adapter for the IBS data has been written in Java code to strip out ship data for processing by the ACORN radar filter, which declutters the commercial track data and classifies other contacts of interest. The ACORN radar filter is written in Python code and soon will be converted to real-time software integrated with ACORN. Another set of code computes course and speed statistics for every ship being tracked and these track statistics are stored in the dynamic AIS ship matrix at the end of each ship's voyage. The static AIS ship matrix has one row for each individual ship in the world and stores over 100 columns of static information about each ship. The ship track shown in this view graph is one of a fishing vessel, showing the frequent changes in course and speed in the fishing area. This track was buried beneath a heavy shipping lane, where numerous cargo and tanker ships were on steady great circle courses with rather constant speeds. The processor produces histograms of each ship's average course and average speed statistics. All the ships exhibiting frequent changes in course and speed, typical of fishing vessels in the fishing areas, are easily extracted from the massive number of ships on great circle routes through the area. Over many years, the storage of the ship track statistics with the other metadata about the ship produces a pattern of life for each ship type in a specific area as a function of time of year. The database of frequent flyers in the area is valuable as a background for detecting abnormal behavior for ships entering the area for a first time, or for ships with no one, patterns performing unusual tracks. The key advantages of the Acorn Data Fusion Processor and the Acorn Radar Filter are threefold. First, the Acorn Radar Filter filters out commercial-only ship tracks, greatly decluttering the ship track data. Second, the Data Fusion Processor data fuses IBS ship tracks with other sensor source tracks that are not included in the IBS data feed. Third, the accuracy of the Acorn Data Fuse tracks have been assessed to be very good in 5 Trident Warrior exercises using Navy ground true tracks provided. The key advantages of the present behavior and pattern of life processor are fourfold. First, the present behavior processor detects 7 types of anomalous behavior without requiring years of recorded ship track data. Second, the present behavior processor identifies AIS ships by ship name or MMSI number and ELINT ships by ship type or class. Third, calculates in real time the statistics of each ship's course and speed and outputs histograms identifying ship patterns, such as naval combatants on patrol, fishing vessels and fishing areas, cargo and tanker ships executing great circle routes. And finally, a static AIS ship matrix and dynamic ship matrix provides a long-term historical database of ship tracks to establish normal and abnormal behavior. The transition of the Acorn Data Fusion Processor and the present behavior and pattern of life processor to programs of record is well underway. The Minotaur Acorn sidecar is now being developed for transition to the Minotaur program into several commercial applications. The same technology is being transitioned to the NAVSEA Cooperative Engagement Capability Combat Systems Program of Record and to the PMW-150 Command and Control Experimentation Program of Record. In addition, NAVSEA IWS-6 is interested in acoustic/non-acoustic track data fusion, since this is a current critical capability gap. Also, DCGSN and Stratcom are pursuing discussions for the transition of the Acorn and present behavior/pattern of life processor capability to their respective programs of record. The Department of Defense transition has been discussed in detail in previous view graphs. The current commercial market of this technology is potentially large. Illegal fishing is a $100 billion market for which the Acorn and present behavior and pattern of life processors are critically needed. Pirate ship activity is increasing, especially in areas like the Red Sea. Illegal drug trafficking is widespread, with drug routes from Colombia and Peru, as well as from Pakistan, to destinations all over the world. Illegal maritime weapons trafficking is also widespread, with countries like Iran, North Korea, China, and Russia supplying weapons to terrorist groups all over the world. Jove is having discussions with Southcom and Fourth Fleet concerning the critical illegal fishing occurring currently in the Gulf of Mexico. There are literally hundreds of similar commercial problem areas where Jove's technology is critically needed. The conclusion from this presentation is that the Acorn Data Fusion Processor and the present behavior and pattern of life processor are being transitioned into several DoD programs of record, and that this technology adds significant capability to solve illegal fishing, drug running, pirate ship, illegal weapons trafficking, and other commercial applications. For further information, please reach out to Dr. James H. Wilson at the contact information listed on this slide.